Okay, so we've got quadrilateral ABCD, and we're given that the two diagonals are bisecting one another, meaning this segment is equal to that, congruent, and this one is congruent to that one. And here we have A, B, C, D, where the two diagonals intersect at point E. What we're trying to prove is that quadrilateral ABCD is a parallelogram. That requires us to go ahead and find out that the opposite sides, both sets of opposite sides in this quadrilateral, are parallel to one another. Now, as you can see, this side is congruent to that one. This side is congruent to that one. If we were to look at these two triangles, ABE and CDE. In addition to two sides congruent to one another, then we've got these two angles are congruent by the vertical angle theorem. Now that we have SAS congruent to SAS in these two triangles, we can go ahead and say that ABE and CDE as triangles, they are congruent by SAS. Since these two triangles are congruent, we can go ahead and say that this angle is congruent to that one by CPCTC. And now that BAE is congruent to DCE, then we can go ahead and say that line segment AB is parallel to line segment CD by the alternate interior angle converse theorem. Then we're going to go ahead and transition to the other set of opposite sides to see if those can be proven parallel as well. As you can see, the same segments are congruent to one another. And then we've got this set of angles right here, opposite and congruent by the vertical angle theorem as well. Therefore, we can go ahead and say that triangle BEC is congruent to triangle DEA by SAS congruence theorem. This triangle is congruent to that triangle. And now that these two triangles are congruent, we can go ahead and say that this angle BCE is congruent to angle DAE by CPCTC. And because of the alternate interior angle converse theorem, again, we can go ahead and say line segment AD is parallel to line segment CB. Now that we've achieved the fact and proven the fact that opposite sides of this quadrilateral ABCD are parallel, then we can go ahead and say that ABCD is a parallelogram by definition of parallelograms.